So I'm Ian Craggs. I work for IBM on the Watson IoT platform, which uses MQTT to connect devices to the cloud. I'm also project lead of the Eclipse Paho project, which implements MQTT clients and some other tools like MQTT Spy, which enables you to look at the MQTT features on a broker, and some test material which I've put together. If I were showing you the slides now, then there would be a history or some of the projects that I've worked on. I've worked on MQTT-related projects since about 2000 to 2002, the early 2000s for certain. First on some IBM implementations of MQTT brokers, and then on the open source versions of the software. The next slide I was going to show would be MQTT was a solution to a polling problem. And one of the first polling problems that I found was putting together the Doomsday Book in the UK after we were invaded by the Normans in the 1000s, 1066. They wanted to figure out what all the taxable, how much tax they could raise from all the population. So they sent out a bunch of people, about 20 people. It took them a year to put all of this together. And the slide I have, as you can't see at the moment, shows a page from the Doomsday Book, which has an entry for the village in which I live at the moment from 1,000 years ago. So that's pretty cool. But the actual polling problem that MQTT was meant to solve was monitoring an oil pipeline. And this had sensors all along the pipeline to measure the pressure and temperature and other vital statistics of that pipeline over thousands of miles in Alaska or some deserts or whatever. And so these sensors had to be connected up by satellite connections to the central server. And the original SCADA sensors had to be polled from the central service. So with 4,000 of these, the central service was soon overwhelmed by all of this polling activity. So MQTT was invented to solve this problem, a very practical problem. You might say, well, MQTT doesn't really have many features. And the reason was it was invented as a minimal protocol to solve these problems with the least features that it could have to solve that particular problem. And as we've gone on, some more features have been added. And this is where we get to MQTT version 5. One of the questions might be going through your mind is why we want a new version of MQTT right now. I just remembered what was next on my talk. So the goal of the standardization process for MQTT was to get something out there quick, because this started in 2013, the standardization process. MQTT had been in the field, used for solutions for a decade or more. But companies were increasingly asking us, or cooperators were increasingly asking us about whether it was going to be a standard, an IDF standard or whatever. And so we embarked on the standardization process, and the goal for that was to get it done as quickly as possible. And that meant we had to change as few things as possible because we didn't want to disrupt the existing applications. So that meant that the charter for the standardization of 3.1.1 was very, very restricted, and we couldn't fix all the things that we would otherwise like to have fixed. So that was done. I think we got it out in 2015, standardization process of 3.1.1 completed. And then we thought, well, we don't want to move things too quickly, but we do want to show some activity. And so we embarked on the standardization process for the next version of MQTT to fix some of those big issues that people had with the existing solution. And those big issues were primarily around error reporting, because not all of the packets, not all of the operations in MQTT allowed errors to be reported back to the other side of the conversation. And there are items to do with large-scale implementations. Originally, when we were talking about MQTT, large-scale meant 50 clients or 10,000 clients, and now we're talking about potentially millions of clients or billions of devices connected to the same service. So that meant that we had some issues to resolve in that. So that's just an indication of where we are today with MQTT. That's just a measure of the website traffic on the Eclipse IoT projects. And then this is a clip from the recent IoT developer survey that has been run for the several years by the Eclipse Foundation. And MQTT is on the left-hand side of this slide, starting from a high base. HTTP is second on that list. And AMQP is in the middle, but on an increasing trend if you're thinking about scaling up your communication between backend servers, then maybe AMQP is something that you want to look at. So just an indication of the popularity of MQTT. I explained this, that the charter for 3.1.1 was minimal changes, get things out quick. So next slide. And there we go. The common MQTT issues up to 3.1.1, poor error reporting, the lack of any metadata, and my argument was always, well, you can put that in the payload and define your own payload if you want, but we've acceded to some of those requests, and now version 5 has some metadata allowed. States required to be held along sessions. If you've got a large MQTT cloud service, then maybe that's an issue for you. And load balancing, again, for large-scale implementations. Next slide. There we go. So when we started out with version 5, first of all, it didn't have a name, so it was called vNext. And then we had an outline, which was of these 4 big buckets to consider the improvements that we should make. Scalability in large-scale systems, improved error reporting, metadata, and a catch-all bucket at the bottom for resource-constrained clients and performance improvements. Can you tell me how much time you would like me to spend right now? Because I'm not sure where I am now.
25 minutes.
Okay.
Max.
Right, yeah. So that's the formal TC charter. It just reworded those big ideas into formal language. And the membership of the TC is on the right-hand side. You might find it interesting that MQTT, according to this definition in the standardization process, doesn't have any, it doesn't stand for anything. It's just MQTT. But because we started the technical committee in 2011, we have this hangover which says message queuing telemetry transport. We're not allowed to change the name, apparently, because that's too difficult. So that really doesn't apply anymore. It's just MQTT. Next slide, please. That's just a history of where we are with the timeline for the standardization of version 5. We started in 2016. Actually, we began in 2015, a bit before that. We're almost at the end. We're on the second, we'll soon have the second draft or customer specification. So we go to the next slide, please. This is the first committee specification. The second one is coming out soon with minor changes. We anticipate that this will all be finished, all the red tape will be done this year. Any further changes will just be dotting I's and crossing T's. There won't be any substantive changes, so you can look at that spec and use it right now. So I'm just going to run through some of the changes, the improvements that we've put into version 5 over 3.1.1. This is the overall list categorized into those big bucket ideas. And let's go to the next slide, please. So I'll just outline the details. We have one new packet. All the rest of the packets stay pretty much the same. This is a auth packet. This is to allow challenge response security exchanges. It doesn't specify, the standard doesn't specify how you should use it, so it's open to use by any security mechanisms you would care to implement. Next slide. Okay. For improved error reporting, we have response codes or reason codes on every response packet. And these are defined in a list in the specification, of which there's an extract on the right-hand side. Principally, any response code or reasons code from 0 to 127 is a positive response. Anything above is negative, and it's just 1 byte for that. So this means that for the publish QoS quality of service 2 exchange, there are four packets that are sent to achieve that. There's the publish, the pubrec, the pubrel, and the pubcomp. Any of these can return an error, and then the exchange stops if there's an error. Previously, in 3.1.1, you only had two options. You either had to continue the exchange till the bitter end, even if you figured out there was an error in the middle, or you had to close the connection completely. So this means there's a much more efficient way of reporting errors to the other end of the conversation. Next slide, please. Okay. For extensible metadata, we also have a list of properties that is available on all packets. If you don't just put any properties in the packet, you just have to send a length byte, so there's just one extra byte. So there's minimal overhead if you don't actually need to use them. We decided not to put them on ping packets because we thought, hey, that could mean people could use them for all sorts of reasons and implement their own protocol on top of MQTT, which was probably not a good idea. There are user-defined properties, and you can have multiple of those. They're just string pairs, so you can use those for your own features if you like. And the rest of the list is predefined, but is used by an awful lot of features that have been put into version 5. So once we had them, we used them. We were able to simplify the management of session state, which to me, that was one of my big irritations with version 3.1.1. Typically, you want to start and finish a complete set of work. You want a clean slate to start with and a clean slate to end with when you finished it. But if you have interruptions to the network connection in between, you want to be able to carry the state over that. To achieve that in 3.1.1, to set things up to start with, you had to connect with clean session true, because clean session cleans the state at the beginning and at the end of the connection. And then you had to disconnect and reconnect with clean session false. In version 5, the clean session flag becomes clean start, that is only cleans the session at the beginning, session state at the beginning of the connection. And there's a separate property called the expiry interval, which defaults to 0, cleaning up at the end, or you can set it to some other value. So you only have to, this is reduced to one connection. In previous versions of MQTT, only the client could send a disconnect, which meant that if the server had some situation where it wanted to tell the client to go away nicely, there was no option other than to close the TCP connection. And then the client application had no idea what was going on, whether to try and reconnect immediately or later, or take some other action. In version 5, the server can also send a disconnect, so the client can know, along with a reason code and the reason string, if it wants a further explanation. That means that the client application can take some appropriate action, more appropriate action. Next slide. We do have a simple request response facility. We did have some requests for this. Very simply implemented. There's a property which is the response topic. So when the receiver gets that, it knows which topic to use to put the response to. And there's also a correlation ID property which you can use to match responses to requests. There's a payload format indicator which has ended up with just two values, binary or UTF-8 strings. We did have quite a few in-depth discussions about how far we wanted to go with this. MIME types were considered. We went for this minimal implementation, and I think I was in a discussion thinking life is too short to continue this because it had probably gone on for quite a while. So hopefully that's going to be happy. We haven't received negative feedback on this particular aspect, so hopefully that's going to keep people happy. There are shared subscriptions, which is a load balancing solution. So with PubSub, if a group of subscribers subscribe to the same topic, then they're all going to get those messages. That's the principle of PubSub. That causes a problem if you have a high volume topic and you want to manage the workload by adding more subscribers. So shared subscriptions are a solution to that. You can set up a group of subscribers, and they use this syntax of topic syntax at the bottom. start with $share and a group name, and then the topic filter. The group name indicates the group of subscribers that are going to be associated with that topic that are in one group. And then the server decides which of those members of the group individually are going to receive each of the messages. So only one of the members of that group will receive the message. There's no algorithm specified in the standard. That's common to MQTT. It leaves the algorithms for these up to the server, not to constrain implementations. That does mean that a server could always send the message to the same member of a group and still be compliant with the spec, but I would say that's an issue with the server and definitely not recommended. There are no local subscriptions like are available in JMS. This is something that people often first encounter when they write their first MQTT application, but now there's an option on subscribe so the originator doesn't have to receive its own publications if it's using the same topic for both publish and subscribe. We have a means of controlling the receipt of retained messages. These are sent when subscribe is received by a server and there is a retained message set for that subscription. This is especially a problem if you use MQTT to bridge between servers, because if the subscription already exists, you don't generally want to receive the retained messages again. So now we have a way of controlling that. You can only receive retained messages if the subscription is new or not at all, 3 different options, as well as the original one. Topic aliases are a way of reducing the packet size for published packets that have a long topic name. The first use of the publish will include the topic name and an alias property, and that's just a numeric value, a 1-byte numeric value, and subsequently the publish packets can then use that alias instead of the original topic name. And finally, this is the last set of features, or it was. Okay, so that set of features was the ability for both the server and client to advertise their capabilities. The one example was the maximum packet size. So on the connect and the connect, then these properties are available so that the client and server can tell each other what their capabilities are. So that means that an Arduino connecting to a server can say, hey, I can only receive a maximum message size of 256 bytes, whatever. So don't bother trying to send me a 2 meg message because I'm just going to fall over in a heap. Previously, the server might have reattempted to send that, and you get into an infinite loop of errors. This way, we can avoid that situation. And there are also various capabilities on the server side, like whether retained messages are available and what the maximum QoS is supported by the server. So that, again, the expectations are set on the other side, on the client application. So we're going to finish off version 5 with the red tape done in 2018. I think that version 5 addresses lots of those common issues with 3.1.1. I don't view 3.1.1 as deprecated. I think they'll coexist for a long time, although we do seem to have a lot of take-up of version 5 already, even though we haven't finished the standardization process. For the standards committee, the next item on the list is probably to look at non-TCP use of MQTT-like protocols, and there is a specification that was published by IBM a little while ago called MQTT-SN, so we are probably going to look at integrating that into the standardization. Okay, implementations. This is the issues list for the MQTT Java client in Eclipse Paho. There's an issue at the bottom which is to do with the design of the APIs, and then we have an implementation which is most of the way through and these are the bug reports on that API. So if you want to get involved, this is the place to go. Next slide. I've written a blog post about the C client. C client is a little bit behind the Java client, but I've got an outline design and I've written the first tests to go along with it. So again, if you want to get involved in that and see where it's going, then look at the blog or go to the Git repo. I'd say that on the face of it, you might think that writing client libraries is easier than writing servlets. But in this regard, writing a server is fairly straightforward in that you have to follow the spec. And you just say, well, that's it, that's done. I have a few configuration options, but I've probably sorted that out previously. But with the client libraries, then you have to decide what sort of API you want, how to expose some of the features to the application. And so in some ways, writing the client libraries is more involved than the server implementation. It's recently been announced that the Eclipse Mosquito Broker is going to have support for version 5 in August of this year. There's a German company that's recently announced support for that development, and the author is working for those guys at the moment. So that's good. That's late August. Obviously, those plans can change, but that's the plan for the moment. For Paho, client-side implementations, we are planning a June release of this year, including the Java client and C client, potentially the embedded C client, and certainly some test material, which I'll just quickly show you. Next slide. There are some other external implementations already in development. HiveMQ has announced that they will have early access support in May and June of this year. VernMQ are implementing already, and there's a new company I wasn't previously aware of until they raised an issue on my C client, just to say you could try this out. So Flespy.com is an online MQTT v5 broker. They claim to be the first commercial implementation. Okay, I'm just going to very quickly. Oh yeah, sure. Yeah.
The cable is really loose.
Okay. So questions while I do this?
I actually have one. Given that MQTT5 seems to be a bit more verbose and that the servers are exposing their capabilities and stuff like that, is it making it harder to make sure that the clients and the servers are secure? And things like, for example, denial of service attacks, things like that. Is this more of a concern with MQTT5? Possibly.
I don't think so. To be honest, I haven't really thought about that. I think the fact that you can advertise capabilities so that you can say, I don't support that more explicitly, I think that is an advantage. Also that because we have these improved reporting mechanisms, I think overall, I don't see that this has changed the opportunities for denial of service. But yeah, I hadn't really, I guess it's possible, but I don't think so. Do you know where the cursor has gone on this, or how I can get to it?
I'm having a hard time, just move around until.
Any other questions?
There's one.
Yeah, thank you for the presentations. Great presentation. So I have a quick question. I don't know if it is appropriate to ask this question. Just curious on the CoAP, because we are talking about the constraint application protocols, which is of course not an TCP, it's an UDP protocol. So can you talk about it? What's happening on that? Whether we can migrate these applications to the CoAP? And yeah. Thank you.
So I haven't followed what's happening with CoAP in depth, but I know that there are a few Eclipse IoT projects that are using CoAP, and as you saw from that Eclipse developer survey, it certainly has this activity. What I have heard, and that this is sort of unofficial, is that people have been thinking about how to get UDP communications through firewalls and the like with long distance. If if you like, to connect to the cloud's services and are having issues with that. So that I believe that there's some people thinking about having co-op type interactions over TCP to get over that problem. And like I said, with MQTT, we're also thinking about having mesh network type capabilities added to MQTT as well. So I think we're coming from two different directions. The jury's out on whether which one of those is going to win out. What I would say is that I thought, because I've had an MQTT-SN UDP implementation available in Paho for several years now, and I thought that we would have more activity in the mesh network area, and we haven't had a great deal. So it's not. It may happen in the future, but it hasn't been as much activity as I was expecting. So that might be the practical problems of using mesh networks on devices, because that was always, each manufacturer had a different implementation, and getting them to interoperate was always very difficult. I can't see my cursor to get to this, but basically this is the command to start the MQTT broker, which in the Paho test material, which supports MQTT version 5. So this is just cloning the Git repo, and then you can set the clone the Git repo, and you can start the broker, and it will run MQTT 3.1.1 and version 5. And I've embedded the specification conformance statements into that broker, so when you run a test against it, it'll tell you how many of those you've hit in the execution of the test. And the other window I had was a first C client test that would run against that broker.
One last question?
Which repo is it going to get that?
Paho.mqtt.testing. I need to update the README on that. That's a good reminder.
Thank you very much, Ian.